Okay, it is now 9:58 on the 26th of July, 2025, and we know what we're looking at here. This happens to be a 30-second exposure of Messier 13 off to the right and NGC 6207 to the left. I have strategically positioned. They're about 30 arc minutes distant from one another. I would like to believe this is actually now north and this is south, but it all depends on where the ZWO imager rotates and positions itself at. The last time I was out, I thought the cluster would be down to the lower right and the galaxy to the upper left, but I may not have really seriously checked that the weight of the ZWO imager is such that if you really don't clinch down on it, it can rotate on you. So let me go ahead with this. I'll just have to check between the two of them to determine what their position is. NGC 6207 on the left is a galaxy in Hercules, magnitude 11.63 by 1.2 arc minutes. It's a lowercase c spiral 38 million light years distant at right ascension 16 hours 43 minutes 3 seconds with a declination of plus 36 degrees 49 minutes and 55 seconds. Now, this is quite a good view of the galaxy, but keep in mind it is a class C spiral, which means very young. This happens to be a brightish line of sight star. This is not the core of NGC 6207. So it's a look, it could be very deceiving in terms of appearances. The view of the galaxy is excellent at 30 seconds exposure. We've had multiple stacks now. You can see a dark lane here. You can see the frontier off in this direction and a spiral arm circling around. And there may very well be an H2 region right in this part of the galaxy. And you see some faint nebulosity here. So that is our kickoff view for the evening, NGC 6207. Now I'm going to plug in Messier 13, and it should center, and I should be able to get the data. Remember that right ascension, 16 hours, 43 minutes, 3 seconds, with a declination of plus 36 degrees, 49 minutes, and 55 seconds. As you can see, Messier 13 shifted from about this position here and moved maybe 20 arc minutes to end up in the upper left-hand corner in that direction of the upper left-hand corner of the screen. Messier 13, of course, is a globular cluster, and we're getting some duplication of the stars in it. I may reinitialize, but right now what I want to do is I want to demonstrate that our right ascension is 16 hours, 41 minutes, 41 seconds with a declination of plus 36 degrees, 27 minutes, 37 seconds. And I have mounted the ZWO imager orthogonally along the optical tube assembly. So when it's parked in the counterweight down position, it is on the very top of the right angle diagonal that is used to mount it. So keep that in mind. I'm going to go ahead and pause now. We're going to reinitialize the stack so we can get rid of the stellar duplication that's going on the screen. And here is our well-defined view of Messier 13. Once again, no stellar distribution. I sat still for a while. I allowed another pass. We're about to complete a second pass since initializing the image. The globular cluster in Hercules is magnitude 5.8, so it's fainter than, let's say, Messier 4, which happens to be a great deal closer. It's 23.2 arc minutes in size, almost as large as Messier 4, but it is about 5 times more distant at 25,100 light years. We're getting a superb view, and I'll give you a hint why. I have installed the OPTOLONG Light Rejection Filter onto the scope in the optical train. Unlike the nebula filter, it only eliminates light that is not usually native to the sky, so it blocks some light pollution light. And the view we're getting here is quite spectacular with excellent resolution. We're at 50% zoom, I'll double check that, which I now believe to be 100, still is 150x, but the initial setting of only 32% zoom is roughly 100x or slightly less. So from now on in the f8 scope, we're going to call this view right here the 100x view, and at 50% zoom, the 150x zoom. Now I often push the scope up to 100% zoom, and there's a reason for it. At 100% zoom, hypothetically, and I haven't confirmed this yet, we are exposing every pixel to light gathering, which means basically we're getting the highest degree, if not of resolution, but of at least the brightness of the studies on the screen. I have to tell you, I have looked through a 30-inch telescope at Messier 13, and this image is brighter to the eye than that, although it does not resolve quite as nicely. So there's our second view of the evening. And from this point on, I'm going to begin to adventitiously explore the 6200 plus series of studies in order to capture a variety of different studies so we can demonstrate to ourselves that putting a light pollution filter, even with an imaging system, is advantageous because what it does is it means you are less prone to have to adjust the histogram. Whereas the nebula filter was very specific to frequencies, you did have to adjust the histogram quite a bit, and stellar magnitudes were diminished by at least 3, possibly 4 magnitudes in terms of sensitivity of display on the screen. We're seeing here, and I've just centered it on the screen, is a faint galaxy, NGC 6201, a galaxy in Hercules. Magnitude 15.5, 0.4 by 0.3 arcminute elliptical, 476 million light years distant. That puts it at about the size of maybe 75,000 light years in diameter. We're at right ascension 16 hours, 40 minutes, 14 seconds, with a declination of plus 23 degrees, 45 minutes, and 53 seconds. We're seeing some duplication of the brighter stars, and we're not really getting much of a view of this galaxy. I'm looking around on the screen. There are other galaxies apparent, but Messier, I'm trying to remember, I think the globular cluster ended up right about here. And I see several candidates for galaxies. This is probably our study here. So I can center it up on the screen, and there is a brighter galaxy to this location. One way of verifying that you have actually seen the galaxy in question, in this case 6201, is based on the data that's provided on the handset, the Gemini 2 handset. However, that data can sometimes be inaccurate due to the fact that sometimes they quote the blue-violet magnitude as opposed to the visual magnitude. This problem gets serious, especially with elliptical galaxies, because the visual magnitude can often be 1.5 magnitudes brighter than the blue-violet magnitude. That particular delta is generally accurate for ellipticals, whereas with galaxies of the SO lenticular class, usually the difference is 1 magnitude, and the least mature galaxies typically have a blue-violet visual light delta of 0.5. So you do want to pay attention to what kind of galaxy you're looking for. Another way to determine it is to go online to theskylive.com and track down various stars. For instance, here I would be looking for these 3 stars kind of pointing towards the galaxy, or possibly this triangle of stars here pointing towards that one. Finally, Steve Gottlieb gives excellent descriptions of galaxies at various apertures and their relationships to other galaxies and stars. So you can verify it that way. But he often quotes a slightly different magnitude, either blue-violet, typically never blue-violet, but always visual in his reports, which are quite extensive. and cover scopes anywhere from 8 inches in aperture early on in the 80s to scopes 48 inches of aperture back in the mid-2010s and later cycle period. So these are ways you can validate it. But let's look at this for a second. If this is actually a 14th magnitude elliptical, not a 15.5 magnitude elliptical, I would suspect it's more like this galaxy here. But if this is actually a 15.5 magnitude elliptical in the visual range, I would assume it's this galaxy here. There are other fainter galaxies in the screen, and I suspect that it would using, for instance, up here, using 30-second exposures, we should get down to close to 17th magnitude galaxies for view. So this should be, the screen should be peppered with many galaxies right on the limits. So the one we're looking at here is probably this one, could be that one, but it is designated NGC 6201. Well, as it turned out, NGC 6203 is very close in location to 62. I believe it was 01, but it could have been 02. It also is a galaxy in Hercules. There was only one click of the stepper motor. This is also a magnitude 15.5 galaxy, but it's larger, 0.9 by 0.9 arc minutes. Now, it should have a lower surface brightness than the last one. So it's entirely possible this 15.5 magnitude could be the 15.5 magnitude NGC 6203. However, this is a lenticular spiral, which means if it's magnitude 15.5 and it's one magnitude brighter on the visual, from the blue-violet, it should be a 14.5 magnitude galaxy rather than a 14th magnitude galaxy. So this could very well be NGC 6203. 486 million light years distant puts it at about the size of Messier 31 at 150,000 light years. It's at right ascension, 16 hours, 40 minutes, 27 seconds, with a declination of plus 23 degrees, 46 minutes, and 28 seconds. Well, all righty then. This one should be fun. We do not have a nebula filter installed. We only have a light pollution installed on this scope. That's an OPTOLONG unit. We're looking for NGC 6210, a planetary nebula in Hercules, which I've imaged previously several times. Very bright, magnitude 9.7, kind of smallish, 20 by 13 arc seconds, has a magnitude 12.5 central star that is located 7,400 light years distant. It's at right ascension, 16 hours, 44 minutes, 29 seconds, with a declination of plus 23 degrees, 47 minutes, 59 seconds, not too far from our pair of 15.5 magnitude galaxies. Now you can look on the screen and you might suspect it's probably this bright star here because things have been centering roughly in this location. But let's see if we can verify through magnification that it is indeed a planetary nebula. Now, one thing I did notice in the past about this planetary, it has these wispy extensions, and they probably occur right at the polar regions of this particular planetary nebula. So what I'm going to do is center it up, and we're going to push the magnification a little bit to see if we can't draw out anything of the centrality of that center star. Now, we're now operating at 220%, which is 600x. Nothing is revealing itself. And if we go even further, we're probably never going to see that central star. We are seeing the grid pattern of the pixelation because we've exceeded 100% zoom. So, effectively, we're basically overpowering the light from this star. But let's see if by playing with the histogram in any way, we can improve the view. And no, that is not occurring. I'm squeezing the histogram out. And I'm going to extend the histogram a little bit, and we see the same basic thing happening. So there's no really good way to view the central star of such a bright planetary nebula. Once again, its central star is magnitude 12.5, but its total magnitude is magnitude 9.7, giving a roughly a 3 magnitude delta. And this concludes the first segment of our imaging for the evening. I've been spending a good deal of time explaining things, but that's basically where we are with this, because we are now exploring the possibilities of using a pure pollution blocking filter, which does not have bandpass regions but excludes light that is normally irradiated by community and domestic lighting in one's environment. All right, we've now moved on to NGC 6219, and this is probably our study right there, to Galaxy and Hercules, magnitude 15, 0.8 by 0.8 arc minutes, lenticular spiral, 423 million light years distant, puts it about 120,000 light years in diameter. I'm going to center it up on the screen a little bit, give you some data. It's at right ascension 16 hours 46 minutes 22 seconds, but further south in Hercules, declination 9 degrees 2 minutes 16 seconds. What we are seeing here is a lenticular spiral, and as mentioned previously, this magnitude 15 could either be its blue-violet magnitude or it could be its visual. If it's visual, it will prove to be magnitude 14, but we are operating at 30 seconds exposures. I would guess that this is more of a magnitude visual 15, which means it would have a blue-violet of magnitude 16 because the delta between blue-violet and visual light in a lenticular spiral is roughly 1 magnitude. And the reason for that is that many of the bright ultraviolet and blue-violet irradiating massive stars, by the time a galaxy gets to the lenticular stage, which is very similar to a flattened disk of a globular cluster, but very large in diameter, most of the stars are middle-aged stars that do not irradiate a lot of light in the blue-violet, but tend to put that light out in the visual. So there is the explanation there. Nice view at 150x, and pushing it now to 100% or 300x, the galaxy becomes much more present, much more like a glowing ball with an aura surrounding it. Our next view, located right here, is an edgy-on appearing galaxy, NGC 6243 in Hercules, magnitude 14.1, 1 by 0.4 arc minutes, spiral of the lowercase a. Lowercase a means basically it's one time removed in galactic evolution from a lenticular, and the lowercase a typically means, I think it means it's on the intermediary line on the Hubble-DeBaculaire's tuning fork, which means it may have more than 2 spiral arms, and it may have a bar. 479 million light years distant gives it a size of about 170,000 light years in diameter. Several other galaxies are associated with it on the screen. Some of these may be neighbors, but are more likely to be line of sight. We're at right ascension 16 hours 52 minutes 26 seconds with a declination of plus 23 degrees 19 minutes and 57 seconds. Here we have an edgy-on galaxy, NGC 6255 in Hercules. Magnitude 12.7, 3.6 by 1.5 arc minutes. So its average surface brightness is likely to be more like 14, maybe 14.5. Average surface brightness is basically calculated by multiplying the apparent length by the apparent width, and then taking the log 2.5 of that value and adding it to the summary or total magnitude of the galaxy. Now, this particular galaxy is a spiral galaxy with a capital B, which means it has a bar, and typically barred galaxies only have 2 spiral arms. Well, these spiral arms are very undeveloped because this is a class lowercase c spiral. 50 million light years distant puts it about 50,000 light years in diameter. And what you want to note about it is there's really no clear nucleus to this galaxy, because nucleated galaxies with bright cores are on their way to becoming more lenticular. They've gone gone through a lot of star formation. I believe our own galaxy is an SAB, so it's 1.5 times removed from the lenticular status, but this one is 3 times removed, A, B, C. We're at right ascension 16 hours, 54 minutes, 47 seconds with a declination of plus 36 degrees, 30 minutes, and 6 seconds. What I want to do here is just play with the histogram just a wee bit to see if we can't make the galaxy more distinctive. Now, when I just played with it, what you're going to notice is this has a bit more of a halo extending around it, less edge-on and more saucer-shaped in morphology. So being very careful with histograms is quite important if you want to bring the most out in any deep sky study. Well, I selected this particular galaxy, NGC 6257 in Hercules, because it's quite faint, magnitude 15.5, which is always fun. I like pushing the envelope on brightness. But what's really intriguing about it is its 4:1 aspect ratio, 0.8 by 0.2 arc minutes in size, which basically means something like 48 by 12 arc seconds. Galaxies are also measured in brightness per roundish arc second as well. So it would be interesting to find out what this one is, and it could be calculated, but can't do that in my head right now. The key to this is clearly an edge-on galaxy, magnitude 15.5, showing a lot of features. I suspect as a spiral, undefined spiral, it probably has a 1 magnitude delta. So this is probably more likely to be a 14.5 magnitude visual galaxy, but I'll have to go to the skylive.com tomorrow to find out what its blue-violet magnitude is, just to determine if we're really seeing a really nice edge-on galaxy that's magnitude 15.5. I can also go to Steve Gottlieb's Adventures in DeepSpace.com to determine what its visual magnitude is, because he tends to only quote visual light magnitudes in galaxies. Okay, this will be our last adventitious study of the night. This is NGC 6264, Galaxy in Hercules. Can't be sure where it is. There are quite a few galaxies on the screen, but I'll tell you something about it. It's magnitude 14.4, 0.7 by 0.4 arc minutes. Spiral with a bar, lowercase b, which means it's twice removed from the lenticular, and it has a ring. All right. So, 454 million light years distant puts it about 100,000 light years in diameter. It's at right ascension 16 hours, 57 minutes, 16 seconds with a declination of plus 27 degrees, 50 minutes and 57 seconds. Now, I have seen 14.5 magnitude galaxies with annularities when operating the 6-inch scope at 30-second exposure times. And there are several here. Now, let's see. If I center this up perfectly, 32%, we should be looking at this galaxy right about here when we zoom in, because that's where most everything has been turning up this evening. So let me push it up a little bit more in magnification to 150x. And sure enough, there is a sense of a faint annularity around this central core of NGC 6264. We have 2 more studies we want to look at tonight. Before we sign off, we're at 8 minutes 37 seconds. You know them well. Let's go have a look. But it's going to require the scope to do an equatorial flip first and some alignment. Time now is 10:41. I hope to knock off at by 11 o'clock this evening. Typical session like this lasts an hour, and it begins probably an hour after, actually an hour to an hour and 15 minutes after sunset. And I will tell you this, the night sky looks really dark overhead with only the faintest luminosity to the south. So maybe we should take a look at something to the south as well. And I will do that now. Wow, here we have the glory of Messier 8, the Lagoon Nebula. Obviously, the lagoon is represented by this swirling, like the ocean, coming in and wrapping itself around the island that is located here and outside the extremities. It's a nebula in Sagittarius, magnitude 5.0 collectively, but 45 by 30 arc minutes in size means it's probably somewhere around 13 to 14th magnitude average surface brightness. The lagoon is located 5,200 light years distant with a right ascension of 18 hours, 3 minutes, 41 seconds and a declination, of minus 24 degrees, 22 minutes, 49 seconds. I'm looking off in that direction, and all I see is the faintest hints of luminosity in the sky due to high, thin clouds. What a glorious view. Let's have a look at the dumbbell next, but I'm going to require the scope be flipped. Okay, here we have our penultimate view of the evening. Obviously, it is the dumbbell nebula in all of its glory. When I was using the planetary nebula filter, the nebula booster, all we could basically do is we could make out the entire nebula as we're seeing here, but all we saw was one star roughly at the very 14th magnitude star at the center of the planetary nebula. I counted them without the use of any kind of filter, and I got at least somewhat, if anything, maybe 24. And I think we would count the same number here. So if you went from 1 to 24 stars, basically it would be add something like 3 to 4 magnitudes in stellar depth to the image without the planetary filter. And of course, the planetary nebula filter is designed to reveal planetary nebulae. Here we are seeing Messier 27, planetary nebula in Vulpecula, magnitude 7.3, 8 by 5.6 arc minutes, 1,300 light years distant with a right ascension of 19 hours, 59 minutes, 36 seconds, and a declination of plus 22 degrees, 43 minutes, and 16 seconds. This view is at 150x. If we climb up to closer to 300x, this is quite a gorgeous, astonishing view, despite the somewhat bloated stars in the field of view. A very fine view indeed, but remember, 30-second exposure times. I have to be careful about disturbing the scope, and I have to wait to a certain cycle in the image capture in order to avoid either streaking of stars or doubling up of them. This is quite wonderful, and it's using a light pollution blocking filter rather than straight down the optical tube or with a planetary nebula filter, which would cause many of these stars inside the dumbbell planetary to simply disappear from view. Our Carpe Noctem view of the evening is NGC 6888. It's called a nebula, but I would call it a novel remnant. It's emissive. And the reason I call it a novel remnant rather than a purely emissive nebulosity stimulated leftover gases from formation of a globular open cluster is there's not really a sense of an open cluster, and there's far too much texture caused by an outburst in its nebulous regions. What you want to look for on this is some reflective, some emissive, reflective nebulosity, and a hint of a frontier in this direction. Finally, what I am going to say before I knock off, and I may have mentioned it earlier, but yes, indeed, the ZWO imager's weight did cause a reorientation of the imager in the optical tube assembly, which basically has set us off without having a good sense of orientation of our views, especially the one with Messier 13 globular cluster and NGC 6207, that spiraling nebula. All right, so with that, I'm going to say Carpe Noctem.